This is the video solution to practice problem A that accompanies sample problem 1.2 in your textbook. This problem appears at the bottom of page 11. The problem asks us to convert the temperatures of 45 degrees Celsius and 90 degrees Celsius to Fahrenheit. We are also asked to determine the difference between these temperatures in Fahrenheit. Let's imagine a Celsius thermometer with the temperatures of 45 and 90 clearly defined. What would the corresponding values be in Fahrenheit? And then, what would the difference be between these Fahrenheit values? This won't be a simple matter of adding or subtracting alone. We'll have to take into account the fact that a temperature change of 1 Celsius degree is greater than a temperature change of 1 Fahrenheit degree. To solve the problem, we'll have to carry out 2 Celsius to Fahrenheit conversions and then do some subtraction to determine the difference or the range of the temperatures in Fahrenheit. We can find the appropriate equation for these temperature conversions on the exam information sheet. Within the section labeled Conversion Factors, we'll be using the third equation on the left side to help us convert from Celsius to Fahrenheit. And within this equation, we see that we'll do some subtraction and then some multiplication to take into account the fact that a Celsius degree is a different size than a Fahrenheit degree. We'll begin with the conversion of 45 degrees Celsius to Fahrenheit. You can see that I've shown the appropriate equation from the exam information sheet. We'll need to substitute our value of 45 degrees for Tc in this equation. Mathematically now, our goal is to isolate Tf. It'll be easiest for us to deal with the 5/9 fraction first. To remove this fraction, we have to multiply both sides of the equation by 9 degrees Fahrenheit over 5 degrees Celsius, and that would be the reciprocal of our initial fraction. Showing our work for this step will result in what you see here. The fractions on the right side of the equation will multiply to 1 or cancel one another. On the left side of the equation, we have 45 times 9/5, which results in a value of 81. The units of degrees Celsius cancel, leaving units of degrees Fahrenheit. The next step in solving for Tf will be to add 32 degrees Fahrenheit to both sides of the equation. We could show this step as you see here, leaving a final value of Tf as 113 degrees Fahrenheit. We'll use the same process to convert 90 degrees Celsius to Fahrenheit. We'll use the same equation and we'll substitute 90 degrees Celsius in for Tc, then mathematically isolate Tf. We can work through the fractions again first by multiplying both sides of the equation by 9 degrees Fahrenheit over 5 degrees Celsius. This will cancel the fractions on the right side of the equation and leave us with a value of 162 degrees Fahrenheit being set equal to Tf minus 32 degrees Fahrenheit. Algebraically now, we'll add 32 degrees Fahrenheit to both sides of this equation and we'll find a final result of Tf equals 194 degrees Fahrenheit. Now we'll find the difference between these Fahrenheit values by subtraction. In this case, the difference ends up as 81 degrees Fahrenheit, 194 minus 113, 81. We could go back to our initial image and plug in the data that we have just determined to make the picture complete. We know our low temperature now as 113 degrees Fahrenheit, Our high temperature was 194 degrees Fahrenheit, giving us a range of 81 degrees Fahrenheit. At this point, you should try to complete practice problem B that accompanies sample problem 1.2 on your own. Make sure that you show your work as you practice, and then check your answer with the values that appear on page 33 of your text.